Alright class, so what we're going to go over today is composite figures. But before we do that, I know you had area homework. Lucky for you, here's the answer key for you to check your work. Okay, so here is 1 through 6. I know that you'll pause it so you can take a look. And here is 7 through 10. Pause it, check your answers, because we need to know about area before we go on to the next lesson. So pause and check your work. Okay, so now that you checked your homework, let's look at composite figures. You need to watch the 4-minute video on Edmodo of how to get access to Microsoft OneNote, which this is where your notes are, as well as your homework that's due Friday. Now, composite figures. A composite figure is a figure that can be separated into regions or parts that are basic plane figures, and we'll explain that in a second. To find the area of a composite figure, what you do is you divide up the regions and find each area of those figures, then sum or add up all the areas. What this means is, if I look at number 1, a composite figure is where you have multiple shapes that make up the whole. So for instance, number 1, I have a rectangle and I see a trapezoid. So what I need to do is find the area of the rectangle, and it says sum, which means total. So then I would be adding the area of the trapezoid as well. So the area of the rectangle is base times height. The base, by property of rectangles, is 23. And the height is 12. When I multiply that together, you get 276 centimeters squared. Okay, this is a two-dimensional figure. It's flat surface. I multiplied 2 letters together, hence centimeters squared, or square centimeters. Now, the area of a trapezoid is half the height times adding the bases. So if you were confused on this in your homework, watch carefully. If this side's 23, then parallel to it, this is also 23. Now, the bases are the two sides parallel to each other that never touch. So it doesn't matter which order you put them in, because you're adding them together, you'll get the same answer. Now, the height, well, if the whole figure, composite figure, is 18, and the rectangle is 12, 18 minus 12 gives me a height of 6 centimeters for my trapezoid. So you're going to do 1/2 times 6, and then multiply what your bases get to be. So for example, half of 6 is 3. 23 plus 15 is 38. PEMDAS. I added parentheses, and I did a shortcut. I took half of 6. So 3 times 38 is 114 centimeters squared. Now I'm finding the area of each figure below. This figure I broke into parts, but now I had to add them all together. So if I add those areas together, the total area of this shape is 390 centimeters squared. Okay. Now let's look at another example. Number 2, I see a parallelogram. Okay. So I'm going to find the area of a parallelogram. Plus, I have 2 half circles, semicircles. 2 semicircles make a full circle, so I'm going to find the area of a circle. Okay, now, from the center to the circle is the radius. So if this is 6 inches, this is also 6 inches. 6 plus 6 is 12. If you rotate your paper, you see that this parallelogram, the base or bottom, is 12. And the height is the right angle. These dotted lines that make a right angle is the altitude or the height of the parallelogram. Multiply those together, you get 60 inches squared. Now, for the circle, it is pi r squared. Well, we already discussed that the radius, the center to any point on the circle, is 6 inches. So I'm going to substitute 6 for r. 6 squared is 36 pi. If you do 36 times 3.14, you get 113.04 inches squared. Add those two values together to get your total area, which would be 173. So the total area is 173.04 inches squared. So this is your final answer. Okay? Okay. Another one right here, number 4. I see I have a semicircle or a half circle, plus I need to find the area of a triangle. A semicircle is a circle's area, but you cut it in half. And then triangle is half times base times height. Now if I look at this, the 16 meters is in the middle, so this is actually your diameter. Half your diameter is your radius. So half of 16 is 8, so in place of r, my radius, I put 8 squared divided by 2. 8 squared is 64. Half of 64 is 32 pi, which you get about 100.48 meters squared. Okay? Now, if I look at this for the triangle, it's half the base. If I rotate this triangle, I have an isosceles triangle. So if I rotate it on its side, the base, the bottom is 16. But the height, I don't know. But I can find it. I'm given 8, 17, and I can find the height. This goes back to Pythagorean theorem. So it'd be the leg squared, the height is what we're finding, plus the other leg equals 17 squared. You square everything, subtract 64 to the other side, take the square root of your h squared, and if I take the square root of that, I would get my height to be 15. So I plug that in for my height. Notice it's going back to what we've learned before. So if I multiply all that, 0.5 times 16 times 15 is 120 meters squared. So now I need to take these two areas, add them together. When I add them together, my total area is going to be 220.48 meters squared. Okay, so that is how we do composite figures, where you find the area of a total figure, but you can break it into parts and then add them together. Now, we're going to next go to shaded regions. Okay, similar idea, but we're just finding the area of what's shaded. To find the area of a shaded region, find the area of the shaded figure, then subtract. Okay, then you're going to subtract the area of the non-shaded. What that means is if we look at number 6, the whole shaded region is a square. If I subtract the unshaded or non-shaded region, which is the circle, I would then get the shaded part on the outside. Okay, so the area of a square is base times height. It just happens to be 25 times itself because all sides are equal. And then when you do 25 times 25, you get 625. And that'd be feet squared. A circle, area is pi r squared. Now if this is 25 feet, if I drop this down, my diameter, which it's like cutting a pizza in half, but the diameter is 25. But I want the radius. So I take half of 25 Half of 25 is 12.5. So if my radius plus my radius should give me my diameter, which is 25. So I plug in 12.5 for my radius and square it. So if I do 12.5 squared times 3.14, I get 490.625 feet squared. Now, you're taking the whole shaded region, take away the circle, the unshaded, to find what is actually shaded in our figure. So I'm going to subtract those two numbers, and what you get is 134.375 feet squared. Okay, so let's look at another example. Number 7, I see I have a rectangle. So the whole shape is a rectangle, but then I'm going to subtract the unshaded, which is a triangle. When you do that, you'll get the picture you see where you just want what is shaded. It's kind of like you were used to doing part plus part equals whole. Well, this is like taking the whole, subtracting part of it to find the other part, which is shaded. Whole minus part equals part that's shaded. So the rectangle's base times height. The base, we can say, is 25, depends on the orientation you're looking at it. And the height is 14, or you might have a switch depending on how you look at it. So 25 times 14 is 350 centimeters squared. A triangle's area is half times the base times height. Now, by property of rectangles, if this is 25, the parallel side is also 25. That happens to be the bottom of your triangle. If you rotate this paper, this is the bottom of your triangle. So I have half, the base is 25. The height or altitude, remember the right angle, dotted lines, tells me the height. So if I do 1/2 times 25 times 11, I get 137.5 centimeters squared. If I subtract that, you would get 212.5 feet squared for the shaded region alone. Okay, I'm going to box my answers. Okay? Alright, so that is it in a nutshell. If you look at number 8, I want you to try number 8. I want you to think about it, please. Please think about it. Pause it. Try it out. And then when you come back, you'll see what the answer is. So try number 8. This one was a little more challenging, which is what I wanted. If you look at this, this is a semicircle. So you need to find the semicircle, subtract the unshaded, the triangle, to get the whole figure. Now, if you look at this, we can find the triangle pretty quickly. Half base times height. So the base, you might see it as 21.6, and the height, the right angle, is 9. Half times base times height, you get 97.2 meters squared. If you look at the semicircle, though, we don't have the radius. We're not given the radius, so we have to use Pythagorean theorem to find the hypotenuse. If I rotate this, this is my slant, which is the hypotenuse. So you would square your legs, add them together, take the square root, and your diameter, this is the diameter, is 23.4. So to find the radius is half the diameter, which we've talked about when composite figures. Half of 23.4 is 11.7. That's your radius. So then I plugged that in blue, 11.7 for my radius. Square it, times pi divided by 2. You get 214.9173. Subtract those two areas you found. And what's shaded is 117.7173 meters squared. Okay, and hopefully that helps and makes sense. I will leave it up here so you can pause it and see the steps. Now make sure you go to OneNote. Watch the 4-minute video in OneNote to know how to get there, because in OneNote under the homework tab is your homework number 1 through 10, still due Friday when we meet again. Alright? Okay, I will see you then.